get these questions quite a bit. What is the difference between things like IsaacSim, Gazebo, IsaacGym, IsaacLabs, Genesis AI, Mujoco, and thought I would come out with a video that explains a little bit of my workflow when I'm developing robots. And I'm going to start with a robot that's already been developed by a good friend of mine, Rob Knight, and he's built an arm that works with Hugging Face Lay Robot, and it's a good descriptor arm. I have it in a box here. I built several of these, but here's a piece of it. Now I'm working on the third one that I've built, and this one I've kind of already done a little bit of the cleaning that it takes to assemble the robot. So I'm actually going to put this whole robot together, and I'm also going to link to Lay Robot and Rob's work and his GitHub repo. So to start, first things first is there is a URDF file that already exists, and the URDF file goes through what the arm is supposed to look like. If you go to Robot Studio, this is what the finished arm looks like. I'm going to assemble the arm, and while I'm assembling the arm, I'm also going to run the URDF file so that you can see what it looks like in Gazebo. You can also see what it looks like in RViz. And we're going to see what it looks like in IsaacSim, possibly Genesis or IsaacGym, and we'll call that good enough. Just to explain the differences between the various tools that you might use. Here's the BOM parts list of bill of materials. As you can see here, you can build this arm, which has a follower arm here and a leader arm there. This is a what's called imitation learning, where you're going to use this trigger and gripper, which is in my box here, totally unassembled. And we're going to use this kind of trigger and gripper to move the arm along, and the other arm is going to follow. So, and you kind of take it and you kind of clamp it to a table, or drill it into a table and everything, or board, and you'll see how this all works. The other part of it is that you can use a camera or your phone or webcam, like the webcam that I'm working on right now, to show with the one arm what the other arm is doing, where it's grabbing, etc. And these are servos that are used. They're called VTech servos. There'll be more about that later. This we're going to do first is, before we deal with the printing of the parts and printers and those kinds of things. So if you're going to follow along, the way to do it is to integrate with the robot here, and there's a getting started with robots real world tutorial, and it kind of goes over. This is the Koch robot, but again, you can do this with any of the robots. The Koch robot uses Dynamixel servos, and this particular robot does not do that. So if you would like to use the Koch robot, go ahead and use that. But the idea is the same. We're going to just look at the differences between IsaacSim, IsaacLabs, which is really IsaacGym plus some more stuff, and then Gazebo, and I think we're going to just look at RViz all together. So that will explain exactly what the software and hardware side of the robot looks like. Here's a robot that's fully defined, fully designed. We can also talk about designing robots. There's a little bit of skill to that. And I'm letting my skills atrophy in that area because I'm focused on the software. I can still design and build robots, but I prefer the software side. And now that we're starting to see generative AI models do design, we're probably going to get into a world where we one day will just really be telling the system what kind of robot you want to build and just go ahead and building it. Okay, so let's get into it. So let's just say I had a robot already, and here is a robot by Rob with the Robot Studio. Really cool videos on his channel. And let's say I didn't know anything about coding at all, and I wanted to design a robot. I found a really good course that you can take for using ROS2, and it's learn by doing manipulators. Really great course. If you just go on Udemy, you can find it. The instructor is quite good, and you see here I purchased this one the beginning of last year, and I went through it because it's not. Yes, I've been doing this for a long time, but it's also still a good idea to go ahead and go through these courses again. There's always something new to learn. Like for instance, you know, I probably skipped over what is this ROS2 kind of thing, and I probably just went into here to look at URDF. But this person goes through the whole setup of ROS2. It also goes back through C++ and Python versions of most of the examples. So I think that's just a great, and I think it's like $15, so it's well worth it. Antonio Brandy is his name, with that Brandy with an I. So I'm going to plug some folks. Nobody's paying me for that, neither is Rob. So here though, there's a URDF file, and it's a well-described file. So here's how we're going to do it. First thing is I'm going to download the zip. I already have it, but I'm going to download it again just so we can go through this whole process. I'm going to extract it, and I'll just leave it in downloads. Replace nothing. No, skip.
Why
right.
did we do wind up?
Maybe we'll just replace all. Who cares?
Okay.
Okay, so here we go. This is the SO arm. There are the VTech software is here if you wanted to follow along and actually configure the motors and those kinds of things. Today we're actually just going to look at the step files. If you look here, there is the arm here. I don't know what these various versions of this means, but here's the arm. This is the URDF file, and this is what we're going to focus on here. This is the URDF file, and the URDF and a mesh is what you want. So I'm going to open this whole package. Inside of workspace, you make list. I think I'll use this one, and I'm going to use the latest compiler. There we go, and that's fine. None of that matters right now. So what we're really interested in is this arm, and I'm really not concerning myself with this because I'm looking at. I want to look at the arm itself just to make sure it is the kind of arm that we would need. Here shows all of the specs for this arm, meaning here's the center of mass, the shoulder rotation and pitch. All this is listed for us. So that makes things quite convenient. And then here, this is the kind of important part. If I look here, this is a URDF file. You might have seen this, or it's a file called the Zacro file, which is basically just a stylized URDF file. And you can see here it references other things. So this is the base. It references shoulder rotation and pitch, all of these files, and they seem to be in this mesh folder. So I'm going to open up the mesh folder and let's look at the base. So it's saying that it can't be displayed because the text editor can't display it. What I have is another tool here in my tool list, or maybe I don't have it. I'm going to search for ROS, and you'll see here that I do have this ROS extension, and it allows us to actually do things like preview the RDF, make the ROS package, those kinds of things. We're gonna operate in ROS 2, so we're not gonna use catkin for this, but we do want that mesh file, so we want to take a look at that. The other thing that I also tend to download is this URDF viewer. URDF viewer, and here it is, URDF visualizer. It's already installed. So when I go here and I take a look at this file, this URDF file, one of the first things I can do is if I Control Shift P or Command Shift P. Let me try that again. Command Shift. Well, that's not working. So I'm just going to go to Control Shift P. I can preview this ROS file. So let me go ahead and do that. And you can see it could not render because it couldn't find the packages in the workspace. Blah 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 blah. That's an easy fix. What we're going to do is just ensure that the file has access to this particular package. So the way to solve that is we're going to go just look for the exact file. Since we're not going to build this, we're going to look at the exact file and grab the exact file. So what we're going to do is find or replace all of these with the exact location of where the file is. And then if I usually close the preview and open it back up, not render. Oh, workspace meshes. Oops, I must have made one mistake. So it turns out it wasn't a mistake that I made. Is sometimes the render inside preview viewer does not work that well. So what I'm going to do is render this in RViz so we can see what's going on in RViz. And the way to do that is you need to download URDF tutorial, and I think if you follow that Udemy tutorial, you can go figure out how to do that. It's relatively simple. First, I just ran it, so just to make sure I wasn't wasting anybody's time. What I did is I'm launching URDF tutorial. Once you install ROS 2, and you can figure out how to do that pretty simply. So you see here now, there's the robot, right? This robot's now, let me just turn off TF for a second so you can see. There's the robot in all of its glory, sitting with the base link here attached to the ground. I can rotate the various axes. It's not, it has no idea about collisions whatsoever. Pitch, roll, pitch, and gripper. Again, it doesn't have any concept of that. So when we actually build a robot, there's a few things we're going to want to do. We're going to make sure that it doesn't, run into itself. Number one. So that's actually an easy thing to do. Lots of different packages for that. One of my favorite is Move It. We can use also IsaacSim to accomplish this as well. So we might do both just to see what happens. Try to keep this video fairly short, so I'm not going to do things that have been done before. But you can see here, this is the robot model. Robot model did come in as it should, and yeah, so that's a start here. So this is now working in RViz. Also, not going to go over these kind of what's happening here. Just know that each joint is publishing what it can do, and like I said, follow those other tutorials to kind of work out what all that means. But just know that this URDF file now describes this robot and its inertial measurements, as well as you can see here, there is a collision shape, but there's actually and it's not as fully defined, so we can actually define the collisions if we want, and that would be necessary if we were going to use this something like Move It, which we will. So this being kind of a baseline tutorial, we'll stop with this, and I encourage you all to get a deeper understanding from one of those various tutorials out there. There's also look in Udemy, there's about 3 or 4 different good tutorials on all of those kinds of things. Okay, let's pause this for a little bit and we'll come back and look at what happens now that we've seen RViz, we'll come back and look at Gazebo, and we'll also look at IsaacSim and IsaacLabs. So cool, we did that. Now, and here's the finished product, very cool. I could go ahead and save this config file, and I can save it somewhere where we're going to deal with this robot, but we're actually not going to do that right now because we're going to build out a ROS2 node that supports this robot and launch files and all that kind of stuff. Right now, that's later in the line. What we want to do is really focus on just what is in IsaacSim. And to that end, I already have IsaacSim. Here's the launcher for IsaacSim. I'm going to launch it, and what you'll notice, particularly in my launch, is I already have ROS2 on this machine and configured, and I encourage you to go back and look at one of those Udemy tutorials to learn how to do that, because it also talks a lot more about your RDF files and Zacro files, which we hadn't talked about at all. Here I'm saying here's an Isaac ROS2 bridge, and the library we're going to use is Humble. So when I start my IsaacSim, it's already going to know about ROS2 and how to interact with it. Again, a little bit different than Now, I want to point out something interesting. I intentionally let the recording go while IsaacSim was loading, and for me that was approximately about 65 seconds, as you see here. Took a while for it to load and ate up a bit of my resources while it was doing that. So this is running on a 4090 laptop, right? So if I was running this on a desktop or in the cloud, I get much better performance. Matter of fact, when I dual boot my machines, typically I get a little bit better performance than this. But this is running a 4090 laptop. I have a 4090 on my desktop as well, so I run that. Is much better. But this is the point that I was trying to make about Genesis. It's a little bit faster, takes up less resources. But this is IsaacSim. This is not IsaacGem or IsaacLab. So We're going to talk about that, or Groot. We're going to talk about some of those. The first thing I'm going to do before I get into importing that file, so I'm going to show some examples here. So I could import robots here. I can do some ROS2 navigation, Carter, move it, etc. if you have move it installed. And then you know, I can load this example scene for Isaac Ross. But first, we're just going to go ahead and let's just pull down a robot. And I'm just going to load it. It's going to have my machine's going to slightly freeze for a second while that's happening. And you can see here, you know, I could move this all individually, or I can make this entirety of the scene move. There it is. All right, and you can see I can still move these individually, or I can grab the entirety of the robot and make it move. So, you know, that's move to pose here. The interesting thing for me, the cool thing about any of these is I can look at the source code, and you see it opens up in, for me, Visual Studio Code. And now I can see everything about importing this robot. So if I wanted to, I don't need to have the viewer at all. As you can see here, if I look in the scripts, there is a viewport and a camera state. And all of this is in effort to open up this Franca URDF file. Right? Frame, all of that. That opens up the URDF file. And then when it's done loading, here it's done loading. It's getting this from URDF file from this location in data. So if I want to find this exactly, I can find exactly where it is. It's in here. URDF, robots, and there's all these available robots here. And so that in this way I can see exactly what's being loaded. All of the Python code is available to me. So if I wanted to take any part of this or all of it, I can go ahead and take it all. Or say I didn't want to have, I wanted to go headless, then as we looked at with Genesis AI here, this is my joint descriptions, just like we had before, and this is you know max force for each joint, stiffness, damping, those kinds of things for each joint. Okay, so. And here I'm saying move the position. So this is very, very similar to what we saw in Genesis, with a little bit less processor being used. But then, you know, we haven't really kicked the tires to figure out, you know, whether it renders with ray tracing like it does here in Isaac Sim. So this is Isaac Sim, and I can easily move things to positions. I can even, you know, if I wanted to train a reinforcement learning based model, I can do this in Isaac Sim. What Isaac Labs is, I'm going to look at the difference between Isaac Sim and Isaac Labs. Isaac Labs is tailor-made to deal with the reinforcement learning training job. This is kind of everything that you would ever need, and Isaac Labs is really that kind of just hyper focus on you know, the training of your robot and simulation. If you think about Genesis, contrarily, Genesis is really focused on that reinforcement learning portion, but it also says later in the future they're going to deal with you know, fundamental forces and collisions and those kinds of things that you would see in Isaac Sim. So you know, if I were to really take a look at, we just looked at RViz, and we didn't go into Gazebo because there's a little bit of changing a URDF file I need to do to make it work in Gazebo the right way. Small bits, but there's still some stuff that we need to do. If I were to look at all of these together, you know, we would say that here I'm in Isaac Sim. In Isaac Sim, I'm able to now, you know, look at the robot. I'm able to look at all of its sensors. I'm able to move the robot. I'm able to move it with real physics, etc. But the focus is not on reinforcement learning. Okay, so I think I beat that one to death. So here we are, we have this, it's open. If you notice, the robot is still open here. So let's go ahead and, you know, just for resource sake, I'm going to close it. But again, I could still run it, you know, in side by side, but we don't need to do that in this particular case. So I'm going to just kill that one just for resources. Okay, and now let's go ahead and open a new scene. We're not going to save this one. Okay, and again, go through all the examples. They're all really cool. So expand that a little bit. All right, so I'm going to go Isaac Utils here, and here are a bunch of utilities that we can work with. And we're going to go through some of these in detail, but really in workflows, this is really want to spend a little bit of our time. We're going to look at this URDF importer, and we're going to look at some other things like the Mujoco importer, robot assembler eventually. But in this particular case, we're going to look here. Fixed space link, I'm going to leave that. Joint drive type, it's either position or velocity. In this case, I'm going to leave it at position. And joint drive strength, right now, let's just not even worry about any of this stuff, and let's just go ahead and leave it at the defaults. There are some things that I would definitely change in reality, but let's not even worry about that right now. So here, it allows us to find that URDF file that we were just looking at. So I'm in downloads, SOR main, and I think we were looking at that URDF file, and I think we were looking at this particular one there, and URDF, there it is. Select URDF. I'm gonna change the output of this. Where I'm gonna put this. I do have a Nucleus server running, but let's not even worry about that right now. Let's just put this in, I don't know, documents. Let's just new folder. Let's call it robot. Okay, select folder. Okay, so now we have this, and we can import it. Now you notice there is our arm looking beautiful. If I run this, nothing really happens because it has no idea about articulations and those kinds of things. So in an effort to not make this thing super long, what I'll do is cut this one here, and then we'll come back and look at like articulations and all of those kinds of things. But just a little walk through what's happening here. So there's my base link, and that's the root joint. Physics fixed, so it'll be fixed now to the ground. And now if I look at the other things like the shoulder pitch, there's a visual, there's collisions, shoulder pitch, there it is. Okay, all of those are there. Visuals, collision, pitch, right? So they're all of the various properties are there, and I actually moved myself out of the way so you can see any one of these. So here's that moving jaw. There's the mesh. The angular velocity and linear velocity that this thing can run at. All these have been imported. Mass, etc. And so this is basically what we need to run this. Now we need obviously joints, and to move a robot you need joints. But so this is the basics of all the points we need to create this particular robot. So we're going to leave this here, and we'll come back and look at some more things later on. But I think this is a kind of good let you know, and we can also view this in Isaac Labs if we were trying to make this video insanely long, which I'm not, and also in Genesis AI. So that's another thing we could do as well. But we're going to leave this here, stop, and I think that's a good enough start for today.